Energy problems in Indonesia are increasing along with the need for environmentally friendly and sustainable energy resources. Bioconversion of biomass into renewable energy offers a potential solution to the energy crisis while reducing greenhouse gas emissions. One form of biomass that can be utilized is quail manure. Quail manure is high in nutrients and microorganisms, which allows it to be processed into biomethane through anaerobic biodegradation processes. Smith and Johnson, 2018. Indonesia, with its large poultry population, produces a significant amount of manure each year. This manure, if not managed properly, can pollute the environment and cause health problems. Therefore, processing poultry manure, particularly quail manure, into biogas is a solution that not only addresses the waste problem but also provides a renewable energy source. Dolan, 2017. Biogas produced from quail manure has a main composition of methane (4) and carbon dioxide (CO2). Methane is the main component of biomethane, which has a high heating value and can be used as an alternative fuel. The anaerobic biodegradation process that converts biomass into biogas involves microorganisms in the absence of oxygen, which decompose organic matter and produce these gases. This research focuses on the potential of biomethane production through anaerobic biodegradation process from quail manure. Biomethane, produced through anaerobic biodegradation processes, has great potential as a renewable energy source. In this process, microorganisms decompose organic matter under anaerobic conditions, producing methane as the main product. Quail manure is known to have a balanced nitrogen and carbon content, which strongly supports efficient biomethane production. In addition, the utilization of quail manure for biomethane production can reduce environmental pollution caused by farm waste. Brown and Davis, 2019. Studies on biomethane production from quail manure show promising results. According to studies conducted by several researchers, biomethane production from quail manure can achieve high efficiency with proper pretreatment and optimal operating conditions. For example, adjustments to pH, temperature, and hydraulic retention time can increase the activity of microorganisms in the anaerobic biodegradation process, resulting in significant volumes of biomethane. Miller and Thompson, 2020. Results and discussion. 1. Substrate and inoculum characteristics. Volatile solids versus are the fraction of total solids that are easily vaporized or degraded through combustion at high temperatures, usually around 550 C, versus consists of organic compounds such as proteins, carbohydrates, fats, and oils that easily burn or break down into gases. This process is often used in laboratory analysis to measure the organic content in various types of samples, including solid waste and wastewater treatment sludge. The versus content provides important information on the biodegradation potential and energy value of the sample. Biogas production can be affected by the organic content in the biomass feedstock, as indicated by the versus concentration, the chemical composition of the manure, fermentation conditions such as temperature and pH, and the carbon to nitrogen ratio (CN ratio) are some of the factors that can influence the possibility of biomethane production from quail manure. Manure with a balanced C or N ratio, approximately 20-30, will provide an ideal environment for the activity of methanogenic microorganisms. In addition, the right temperature can enhance anaerobic fermentation and biomethane production, usually in the mesophilic 30-40 C or thermophilic 50-60 C range. Smith and Thompson, 2019. The BMP test results showed that the cumulative biogas production from the inoculum was only 15.98 milliliters per 20 grams used. The figure also shows that in quail manure, biogas production occurred within 1 day and reached a peak after 7 days. The final cumulative biogas production from quail manure after 7 days incubation at an I or P ratio of 2:1 was 116.287 milliliters. Using the theoretical methane concentration from Buswell's equation, the cumulative methane potential was found to be 0.03297 cubic meters for GGVS. 37th day, the anaerobic biodegradation process runs optimally on quail manure and inoculum. However, shows a high difference in the production of quail manure compared to inoculum 10307 This indicates that quail manure is degraded to form biogas optimally. During day 0 to day 7, methane production has a positive value as a result of its considerable volume of methane. Quail manure has a huge capacity to produce biogas. According to research, in this study, quail manure produced about 5.404 cubic meters of methane. This can generate 21.615 kWh of electrical energy. This shows that quail manure is a very effective renewable energy source. Quail manure produces more methane per kilogram than other organic materials such as tofu pulp and wild macroalgae. Since the experiment only lasted for 7 days, the results of the BMP process can be compared to tofu dregs, the residue from the tofu making process, which has enormous energy conversion potential. Abdullah and Zulkifli 2021. In the study, 74.42 kilograms of wild macroalgae can produce 14.88 cubic meters to 37.21 cubic meters of methane, which is equivalent to 59.52 cubic meters of electrical energy to 148.8 for cubic meters E. This suggests that wild macroalgae helps to increase the carbon to nitrogen CN ratio in the feedstock mixture, which is crucial for improving anaerobic fermentation efficiency. Budiono et al. 2020.
Alright, let's talk about exciting results of our study. This study revealed that quail manure has a great potential as renewable energy through the anaerobic biodegradation process. We managed to produce cumulative biogas of 116.2.8 milliliters. Pretty impressive, right? Now let's dive into the specific. We found that specific methane potential or SMP of quail manure is 0.033 millimeter cubic. Versus, to put that into the perspective, you can produce 21.615 kilowatt of electrical energy from just 1,000 kilogram of quail manure. This result confirmed that quail manure can be sustainable energy resource. And what does this mean? It indicates that quail manure is a great fit. And what does this mean? What does this mean? It indicates that quail manure is a great feedstock for biomethane productions. By creating optimal conditions, we can enhance performance of ABP, enabling efficient biomethane productions. Compared to other biomass resources, quail manure produces biomethane with good quality and quantity, so definitely worth considering. Quail manure is an effective and sustainable renewable energy resource. And there you have it, a conversational breakdown of our study results. Cool, right? And in case you were wondering why my voice is kinda weak right now, I'm freaking tired. I'm sorry. And that's it. I hope this video is educational, although it might be not. I'm sorry. Anyway, that's it. See ya.
Thank you.